Hi, good morning. So as you have heard, my talk is about faster backup restore from Proxmox Backup Server. And my name is Adam Kalisz, and thank you for coming to my talk on Sunday morning. So, first of all, what is Proxmox? So when I say Proxmox, I mean usually Proxmox virtual environment. So this is basically an all-in-one virtualization solution that you can use instead of VMware, Hyper-V, and some other options. And there is also a Proxmox Backup Server, which is a backup appliance that is suitable for use with the Proxmox virtualization environment. So if you want to back up your virtual machines, your VMs, you can use Proxmox Backup Server to do that even better than if you just import some storage. Both of those are based on Debian with some other components like Seth and ZFS and some like SDN components. So when I came to the project, the status was that restoring from Proxmox Backup Server was rather slow. It only restored about 250 to 450 megabytes per second, which is quite slow on modern hardware. When I say these numbers, I usually mean mostly incompressible data. So, of course, if the data is compressible, then the speeds would be faster. But in reality, you are not actually restoring any kind of data, or you are just expanding the data. So the transfer speeds would still be in these ballparks. And why are we even caring about the speed? Backup restore. If it takes longer, then it just takes longer, right? Well, it's not so simple. You have service level agreements, so you actually need to restore in some predefined time. That is the recovery time objective. And if you say in the contract that you will restore under an hour, then if you don't make it, then you will pay extra or have to return some kind of money back. And you don't want to do that. The target with our customer was to restore with the speed of 1 gigabyte per second, so about 3 times faster. And of course, I'm still talking about hardly compressible data. The idea was also that we should implement it in such a way that it's a supported and maintainable solution. So ideally, submit it and include it in the Proxmox project. Well, and what was the challenge here? Just make it faster or buy better hardware? Well, it's not so simple. The hardware was pretty good already. We are talking multi-core CPUs, 1 terabyte of RAM, 200 gigabit per second network interfaces, NVMe SSDs all the way. So the hardware wasn't the culprit. The challenge was that it was slow for unknown reason. Nobody really knew why it takes so long. So we had to find the right place where it's slow and improve it. It was getting slower the more incremental backups you had. So with 14 or 21 incremental backups, if you want to keep the last 2 weeks or 3 weeks of backups every day, it would be slower. And also we couldn't just switch to some other software because it would be way more expensive. So how did we start the investigation? Well, we rented 2 boxes at Hetzner, bare metal boxes. quite speedy ones, but not as great as what the customer had. We used Proxmox installed on the ZFS file system because you can tune it much easier. And then we looked at the utilization of various, CPU time and so on. And we found out that basically the hardware is not giving its best, basically, basically the software wasn't utilizing the hardware fully. So we set up a small representative test environment and did all the incremental backups with incompressible data and so on. And we also set up a build environment for Proxmox, so we can actually change the software, build it, and deploy it. And we found out that basically when you restore a virtual machine, then you use QM restore command line tool, or if you click in the user interface in the GUI, then basically in the background the QM restore tool will be started. And it's just a Perl script, very short one. And in the background, it basically starts PBS restore, and that basically calls into a library. And this library is built from a number of files, basically in Rust code. And the important file we found out was restore.rs. And in the repository Proxmox Backup QEMU. So I didn't know any Rust before that, so I needed to learn a bit of Rust at that point in time, which I did. There is a 3-hour tutorial by Derek Banas, which was just enough to get me started. I thought my head will explode, but I made it, and in an afternoon I was ready to look at the code and understand just enough so I can make some changes and look at if I'm thinking in the right direction. Also, I had some help from LLM. We used the Google Gemini 2.5 Pro. So we pay for the Google Workspace anyway, so we can just use it as well, right? And so, yeah, we changed some things and built this libproxmox backup QEMU, and look and behold, that was we found out basically that the network has 8 times higher latency than the NVMe SSDs, and that it looks like the network latency is the problem in some way. And why is that? Well, if you look at how the backups are structured, you have an index file, and that basically says which chunk of the data you back up is a 0 chunk, so you don't have to back it up because you can restore it basically anytime, or how much data you want to take out of the image in the chunk that can be maximum of 4 megabytes large. And basically you take out these chunks and make a hash, and then you compress those chunks and back them up. And if another chunk is the same, then you can just store a reference. You don't have to store it twice, so you can basically run some kind of deduplication. And, well, the problem is then, if you want to restore, then you have like these chunks that can contain data, and these chunks that contain basically, or are just a reference, 0 reference. So when you restore, then you have to ask the backup server to give you the data chunks, and the 0 chunks you can just create, right? So the diagnosis was that basically when we have 0 chunks, then the restore is quite fast because we are just creating 0 files or 0 pieces. And then when we actually have data chunks, then we are taking very long to fetch those. And what was happening was that basically We asked for a chunk, then we waited until the chunk returns, then we asked for another one. So basically the latency between the Proxmox virtual environment and the Proxmox backup server was the limiting factor. If the latency was 0, it would all run very fast, but the latency is never 0. So the higher the latency, the slower it was, basically. And so what we did is we basically rewrote the inner loop and said, okay, when you encounter a 0 chunk, then restore it immediately. And if you have a data chunk, then basically say, I will fetch it in the future and put it to the side for now. And when we have restored all the 0 chunks, then at the end, basically we go and in multiple threads, we start to fetch the data chunks and restore them. So basically, that means if you have a VM file with some 0 pieces somewhere in between, then you have restored basically these chunks all over the place, and then later on you come in and say, okay, like these data chunks in some kind of order from the beginning, more or less, you are restoring them. So it's not in the same order as you stored them, basically. So it's kind of shooting all over the place. But this is a brute force approach, but it was way faster, and so we knew, okay, we are on the right track. We submitted these changes to our customer and even the Proxmox community, and they liked it a lot, but they said, okay, look, we need to rewrite it in our own way to make it more, to make it fit in the project. And so Dominik Čapak of the Proxmox team, he went in and basically in a few iterations, he rewrote the solution in such a way that they liked it. It wasn't that different, but basically he is just using some asynchronous pool and worker threads to do more or less the same thing, but the difference is that basically all the chunks are restored in the same order as they were stored, or that they appear in the virtual machine backing file or backing storage. And so this solution is slightly slower than what we did, but it's more efficient with the resources. And all these changes are now included in the Proxmox 9 release, and even you can download an upgrade for the Proxmox VE 8.4. So just update and upgrade, because it's Debian. So this is what we did, and there are also other speedups we talked about in the community. And well, one of the speedups is that on the Proxmox Backup Server, we could actually fetch the chunks in a smarter way, in a more concurrent way, in a parallel way. And this would lead to another speedup. We don't know how much yet, but it should be significant. So this is one thing to look out for. There are patches that you could apply yourself if you are really willing to, but sooner or later these patches should end up in the Proxmox Backup Server in some form. There are also ideas how to improve the concurrency in other places in the Proxmox platform, basically. And yeah. So the takeaways are, we are now about 2.5 to 4 times faster. What I have seen depends on the hardware, depends on whether your CPU has SHA, calculation acceleration. what the clock is of the CPU, because of course the higher clocked CPUs have an advantage on context switches and so on. And of course, you have to also check the settings of various components, for instance, the network interface ring buffers. So don't forget to check that you don't actually have a bottleneck somewhere else. It's now feasible to replace Veeam with PBS in even more cases. So you can save a ton of money. That's good news. And even better news, we can speed it up even more. And of course, this is a good showcase how a third party, like a small consultancy, can improve some project, even though they are not the owner of the software originally. These people were complaining for 5 years about the slowness of the restore, and so anybody can come in and improve the situation. And also, it is a good showcase how performance debugging can save a lot of money. And in the presentation, if you want to look it up in more detail, I included some sources, so you can look at the code and you can read the article at Lupa by Honza Sedlak. It's in Czech, but automatic translation works. And I would like to thank you to Čmis and Václav Svátek for sponsoring this work and making it happen. Thank you for your attention.